Alright, back at it here for the second video on the hypothesis test for one proportion. Anyway, here are the steps again. Just want to recap those. We're going to determine the hypothesis. We have the null and the alternate. That can be written a couple different ways. We'll draw and label a picture of the distribution. Sometimes I like to do that after I calculate the test statistic. Then we'll calculate the p-value, make a decision based on comparing the p-value to alpha, and then interpret it. Now, we don't have a lot of questions in WAMAP that have you do all of those steps. So I'm going to get this stuff here ready. But here is a question from 5.3. Test the claim that the proportion of people who own cats is smaller than 10% at the 0.005 significance level. So, a couple of things. I'm going to zoom in just a little bit. We know our proportion here is 0.1. That's just 10% as a decimal. And then we have here an alpha. Now, I know I want to probably find Q, and then I'll need N, and I'll use those things to find the standard error. And then I'll use find a test statistic, but I'm going to just put an alpha here. This is our error range, and then we're given here 0.005. So just some of the stuff gathered from right here. Now, our null and alternate hypothesis, the proportion of people who own cats is smaller than 10%. So our null hypothesis is that it's going to be P is equal to 0.10. Our null hypothesis is always that it's equal to something, and our alternate then is P is less than 0.10, and that makes this left-tailed for the test. This is a left-tailed test. So we've got that action happening so far. And if I go through here, I've got proportions, so some wrong answers that are close here. This is for means. Right here, this is what we're talking about, our null and alternate hypothesis. Again, since we have a less than for our alternate hypothesis, this is left-tailed. Now, based on a sample of 600 people, so our N here is 600. I can 1 minus P is going to be our Q. And we can use all this to find our standard error, which is the square root of P times Q divided by N. So, stuff we're going to need down the road are, based on a sample of 600 people, back to the problem here, 6% own cats. So this is going to be P hat. Our data give us 6%. And that's 0.06. So we need a test statistic. Our test stat is going to be P hat minus P divided by our standard error. And just letting Excel do all the work for us here. So, again, I like to find the test statistic first before I do the picture here. But our picture here, since I want you to draw it, I'm going to draw it, and we'll see how this goes. I've got a normal distribution. Proportions are normal. My test statistic is -3 point something. And this is partly why I like to draw it after. Because this is left-tailed, my p-value is going to be this area to the left here. So that's what the p-value is. And the p-value is really kind of like, what is our chance of getting something outside, or having our error range here be less than this guy. So our p-value is just telling us our error range. Okay, so test statistic here, -3.265, so that's going to be a 7, rounding to 2 decimal places. The p-value here, again, this is left-tailed, so to figure out our p-value, we are looking for the area left of this z-score. So we have a normal distribution, And essentially here, this is a normal standard distribution because it's a z-score. And we want the area to the left, so it is true. Again, essentially what we've done with our proportion, our test statistics gives us a z-score, and then we need the area to the left of it. We're supposed to round this to 2 decimal places, so I think it's 0. A lot of times our p-values are listed to 4 decimal places. So this one, if you went to 4 decimal places, it would be 0.0006. I'm going to put that in there just to see. I don't know if it'll accept it or not, but so far so good. So now in making our decision, we have to see if this p-value is less than our alpha here, and our p-value, there's an extra 0 in here. So our p-value is less than alpha. So p-value is less than alpha, so we reject the null hypothesis. We'll reject the null hypothesis if our p-value is less than alpha. If we reject the null hypothesis, then there is evidence to support the claim that the proportion of people who own cats is smaller than 10%. So kind of getting into the context. If we reject the null hypothesis, then there is enough evidence. If we do not reject the null hypothesis, then there is not enough evidence. So we'll see how this goes here. Oh, it accepted my 4 decimal places here. Again, kind of working on the uniformity. I'd like all p-values to be to 4 decimal places, but if it says round to 2, and it should work. This essentially is 0 anyway. So this is one question, kind of ran through with all the parts. Again, we have our null hypothesis, then our alternate hypothesis. We have a picture of our distribution. I like to do that after I know the test statistics so I can see what's there. From the picture, we can see where our p-value is. We use our test statistic and function here to find our p-value. Then we make a decision. We reject the null hypothesis because our p-value is less than alpha. And then that means that there is enough evidence to support the claim that the proportion of people who own cats is smaller than 10%. And that is at the 0.005 significance level. So there's one question, a left-tailed test worked out all the way for you. I'll probably make another recording with maybe a right-tailed and then a two-tailed. So we'll see how it goes. Let me know if you have any questions.